Hello and welcome everybody. This is Noah, and in this video we're going to look at how to multiply rational functions. Alright, we are going to look at three examples here. Our instructions are simply to simplify the following products of rational functions. I think I'm probably going to want a little more space. I'm just going to do that now before I get going. Thank you for your patience. I'm just predicting the future, and then I'm going to want more space here. So, okay. The first example we have is y squared plus 7y plus 12 divided by y minus 6 times 5y minus 30 over y plus 4. So what we want to do with this is we want to factor anything and everything that we can. So the y squared plus 7y plus 12. We think about how this factors. This is going to be, we need a y times something y. We need a 3 and a 4 will make the 12, and they will add to 7. So we can factor this as y plus 3 times y plus 4. And then we have that over y minus 6. And then this is times the 5y minus 30. We can factor a 5 out of this to get 5 times y minus 6 over y plus 4. So now that I've got that, I realize that the denominators have implied parentheses around them, and we can then cancel the y plus 4 top and bottom, and we can also cancel the y minus 6 top and bottom. And what we're left with is y plus 3 times 5. And we'll go ahead and distribute that to get 5y plus 15. That's it. That's all there is to this. We want to factor anything that we can, cancel anything that we can to reduce everything as much as possible, and then go ahead and just multiply out at the end there. So that's it. Just step one. Oopsie. Step one. Factor anything you can. That can factor. A little redundant there. Step two. Reduce or cancel common factors, top and bottom, right? Not across. And then go ahead and simplify in any way that we can after that. And that's it. So that's all the steps we have to worry about. Let's do another example. And is we can get some more complicated factoring that might need to happen. So for this first problem, I'm going to look at the top left piece. Okay, let me read it out. We have x squared minus 4x over x squared minus 4 times 4 minus 4x plus x squared over x squared minus 4, over 20 minus x squared. I read the first one. Let me do that one more time, just to be clear here. X squared minus 4x over x squared minus 4, all times 4 minus 4x plus x squared over 20 minus x squared. Okay, so the x squared minus 4x on the top of the left fraction, we can factor out an x, and we'll be left with x minus 4. On the bottom of this first fraction, we have a difference of squared, x squared minus 4. This can factor as x plus 4 times x minus 4. And we'll see that we're going to be able to cancel the x minus 4s right away. The second one, let's actually change this around a little bit. We've got, I'm used to seeing this as x squared minus 4x plus 4 over, on the bottom, negative x squared minus x plus 20, right? We're just used to seeing it in that order. Technically, we don't need to do this step. You can try and factor without switching that order, but a lot of the time it's nice to put it into what we're familiar with. So the first fraction, we're left with x over x plus 4 because we reduced the x minus 4s. And we'll go times. The second fraction now, we want to factor the top and the bottom. The top's not so bad. The x squared minus 4x plus 4. We need an x in the first positions. And it looks like we want a minus 2 and a minus 2 to multiply to be 4 and add to be negative 4. The bottom one's a little bit trickier. If I have negative x squared minus x plus 20, that minus in front of the x squared is going to give us a little bit of grief here, a little bit more to think about. So I'm going to need negative x in one of the positions. Oops. Touch screen error there. Negative x in the first position and just an x in the second position. And then we need 4 and a 5. And this could be, I'm not sure which direction. Let's try positive 4 and positive 5 like this. And this will give us negative x squared, and then minus 5x, and then plus 4x, and then a plus 20. And that works. That will add up to negative x. So we just want to be careful with that negative in front there. Make sure we're taking the time to making sure that we're taking the time to not make mistakes as we go, unlike me making sure that I'm taking too much time and making mistakes in how I talk. So I can just plug that in. That factors as negative x plus 4 times x plus 5. And then we'll look for anything else that reduces. It doesn't look like anything else does, right? We've got something that's close, that x plus 4, but that's a negative x plus 4 on the other side. And those are both on the bottom anyways, so it looks like we are pretty stuck here. So all that we're going to do then is the top is x times x minus 2 times x minus 2. The bottom is x plus 4 times negative x plus 4 times x plus 5. And really we could stop here. This is okay. But we might feel like multiplying all of these out. So we could have on top, I'll leave the x for a second. We'll get x squared minus 4x plus 4. On the bottom, I'll leave the x plus 4. And then the other one was negative x squared minus x plus 20. I'm able to do that so quick because that was what we had above already. I'm just multiplying back into that. And then I can distribute the x across the top to get x cubed minus 4x squared plus 4x over. The bottom's going to get a little messy here. We're going to need, let's do that over on the side. X plus 4 times negative x squared minus x plus 20. This will be negative x cubed, and we'll get a minus x squared, and then a plus 20x, and then distribute the 4 across. We'll get negative 4x squared minus 4x plus 80. And combine these, we'll get negative x cubed minus 5x squared plus 16x plus 80. So I'll just put that in over here. Negative x cubed minus 5x squared plus 16x plus 80 for our denominator. And just to be clear, these two steps are optional. So having it in the factored form is actually a really nice thing to have as we're analyzing some of these. So while we're doing the practice, you can multiply it out if you want to, but you don't have to. All right, let's do one more. Here I've got something with more than one variable. We have p, q, and r, but we're still going to just use our same kind of reduction rules. I'm going to look for anything that I can cancel. Like I have a p squared on top and a p on the bottom, so I can cancel. That's the p squared is like p times p, so I can cancel one of those from the top and the bottom. the q's now, I have 4 q's on top. That's q times q times q times q. And on the bottom, we have q times q. So I can cancel 2 on the top and the bottom. So that's going to be leaving me with q squared on top, just 2 of them left over. For the r's, we have 1 on the bottom and 2 on top. So we can cancel the 1 on the bottom with 1 of them on top. And then the 9 and the 3 also reduce. The 9 can reduce to a 3. The 3 reduces to a 1. So it looks a little complicated, but as we break it down just in steps, I just look at the p's, then I just look at the q's, then I just look at the r's, and then I look at the numbers, and I've really gotten through all of this problem. On top I have p to the first, which I'll just write as p, times q to the second, times 3 times r to the first. So I'll put those ones there for now. I'm going to do one more line. On the bottom, we have a 1 times that r reduced to just a 1. The p canceled and the q squared canceled. So that's just a 1 times 1 times 1. So this will be 3p q squared r. That's it. So that's not so bad, right? All right. Functions by each other. I was going to say something else. And I guess I was just going to say, like, when we're multiplying rational functions, just be sure to reduce, like factor, then reduce wherever you can, and then look to simplify. But make sure you've completely factored. If you've missed a factorization, you can miss a reduction opportunity. So we have to do that factoring completely first before reducing. Make sure and reduce completely, and then we'll have the simplest answer that we can come up with. All right, thanks for watching, everyone. Go ahead and give those now you try problems a shot. We'll go through those solutions in a minute.